Alrighty. Hey guys, we're beginning Unit 2. Obviously, we started it this week, but now we're going to look a little bit deeper into some of the topics that the College Board actually wants us to cover. All right. So Unit 2 is all about population and migration patterns and processes. So a couple of big ideas in this unit, right? If you remember the big ideas, this comes from the CED. All right, we're going to be trying to answer a couple of these questions, right? How does where and how people live impact global cultural, political, and economic patterns, right? How does the interplay of environmental, economic, culture, and political factors influence changes in population? And how do changes in population affect a place's economy, culture, and politics? All right, some of the big questions for the unit. All right, and the first topic is about population distribution. All right, we're also going to be talking about population density, so it's kind of two in one. Right. Hopefully, the enduring understanding you take away from this lecture here is that you should be able to understand where and how people live is essential in understanding global, cultural, political, and economic patterns. Okay, and a couple of the learning objectives, right? So take a look at those. I'm not going to read those off, but we'll be talking about factors that influence distribution of human population. We'll be talking about different population densities, and we're going to be talking about the impact consequences of population density. All right, so the first learning objective. All right, before I begin the study of population geography, those who study, the geographers who study population are called demographers, and the field is called demography. All right, so we break down the word, it's just the study of people, right? The study of Earth's human population, and specifically through statistics. Demography examines the size, structure, and movements of population over space and time. All right, and these would be the questions that they normally ask, right? Why do people live in certain areas? What is life like living in different places? Where is Earth's population distributed? Where have we seen major increase in population? So on and so on. All right, more questions than this, but these are some of the big questions. All right. Obviously, we looked at where population is most concentrated in the world. And through this cartogram, it's pretty easy to see where, most of it is in South Asia, right? Southeast Asia, East Asia, is that right? So much of Asia and Europe, all right? Lately, though, we've seen population grow in North America, specifically in the United States. And a lot of geographers predict that much of the population growth in the future will occur here in Africa. All right, so this is from 2013, obviously in 2020, it's about 7.8 billion. All right. So these, major population patterns of distribution, right? 2/3 of the population are clustered in the four regions: East Asia, South Asia, Southeast Asia, and Europe. All right, and you can see the different kinds of statistics that are among these four regions, right? So, like in China, right, 50% of the population is rural. Japan and Korea, 75% is urban. In Europe, 3/4 of people live in cities. Fewer than 10% of the population are farmers. And in Southeast Asia, right, 600 million people live in a series of islands in between India and the Pacific. Indonesia is the fourth most populous country, and so on and so on. There are other clusters of population, like the Northeast, here in the US, Southeast Canada, right, Africa along the Atlantic coast, specifically in Nigeria. It's over here, right? Okay, so yeah, East Asia, Southeast Asia, and Europe. And you can see at least 2018, right, the population, right? Europe in total held about 710 million, India 1.3 billion, China 1.4 billion, right? And obviously maps show, how these people are distributed in the world, right? So through this map, which is also in your book, right, we can see that, North and South America have about 1 billion inhabitants, right? And we can see just how many people live in these small areas of China, Korea Peninsula, India, these islands here. Okay, right, population distribution, we can see it in this map here. Take a look at that, all right? But obviously this is all important. And we can also see, how through scales of analysis, different trends, right, in population and where they're dispersed, all right? For instance, if we look closer at China, right, at the local scales of analysis, right, we can see that, much of the population, even though one map might tell us, like this one, that, oh, there are 1.4 billion people spread all over China, right? Looking at it locally, right, we can see that much of, the population in China is centered around, coastal areas, right, near major rivers in China. Same with India, right? We can see that much of the population is centered here in the north, right? And the reason why, we've got the Ganges River over here, right? So looking at it through different scales, we can make a lot of interpretations here, right? And that will lead us into population factors, all right? And why people choose to live in certain areas, right? But before we dive into that, these permanent clusters of settlements, that we've seen in these maps here, those in Asia and Europe, right? Right, these are called ecumene zones, right? Places hosting permanent human settlement, all right? And throughout the course of history, right, the ecumene has grown larger as humans have dispersed, right? As technology and innovation, they've allowed us humans to adapt to new environments, all right? So almost 90% of all people live north of the equator, and about 2/3 of the world's population are concentrated within 300 miles of the ocean or an ocean, right? So that leads us into our population factors, right? There are two kinds of factors that determine where people live. The first of these is physical factors, right? Also called site and situation factors. So when people decide where to live, I think one thing needs to be kept in mind, right? People need to have their basic needs met: food, water, shelter, security, right? And by looking at physical factors, some of these can be met, right? Human beings, right? They want to make sure that, the climate is fitting, right? So most human beings live in the temperate climate zones, right? Where there's moderate temperature, moderate precipitation, right? Basically in the middle latitudes, right? 30 degrees north, 60 degrees north latitude, right? And 30 degrees south, and 60 degrees south latitude, right? So you can see through this diagram here where exactly human beings would like to be concentrated. So just a little bit above the equator, just a little bit below the North Pole here, right, where the ideal climate is. And along with that, human beings also take into consideration, landform, the physical environment, right? Human beings, generally speaking, over the course of history, have lived in lowlands, right, due to the ease of building, planting, transporting goods. These areas, provide places to grow crops, right? They provide fertile soil, potential to grow food, right? And more importantly, human beings settle near fresh water, right? Areas adjacent to rivers, these typically have rich soils. Water is essential for sanitation and hygiene, and also for trade and communication as well, right? And you could look at basic examples throughout history that show this, right? You could be looking at London, you could be looking at Rome, right? You could be looking at in colonial times where people decided to settle in the United States, right? And of course, it's common sense, we need water to survive, right? And of course, there are some exceptions to these rules, right? Like Mexico City or Quito, Ecuador, right? They live in high elevation, but those are due to other reasons. But those are the exceptions, right? Where people don't live, though, is also as important, right? People don't want to live anywhere that's too cold, that's too wet, that's too high, too dry, right? In Earth, about 20% of the land on Earth is dry. People don't want to live in wetlands because, rain and heat deplete nutrients. You don't want to live in cold lands, right? It's hard to grow crops, and also it's really hard to live in those harsh conditions. Highlands, steep, snow-covered usually. Some plateaus at lower latitude are more densely populated, as I was saying. As are some mountain regions, but those, like I said, come from other reasons, cultural reasons, right? And you can compare these two maps here just to see, that people do want to live, right, near water, right, in the temperate climate regions of the world, right? So the temperate zones, as you can see in green here, it's tropical zones, right? 15 degrees, 20 degrees north latitude, right? You can also see where people don't live, right? And the polar and subpolar zones, right? makes sense, right? You can compare this on your own here and take a look. All right. So the second set of population factors, right, that determine the influence of the distribution of population are human factors, right? So human factors include economic factors, political factors, cultural factors, and historical factors. All right, but let's look at two right now. All right, economic factors. So people are going to want to live in areas where they can earn a living, right? Obviously, right? Ports, areas with good roads, railways, and airports, usually are signs, the places economically well, industrialized areas, developed areas of tourism, right? So on this map here, not only are these cities some of the world's most populated, but also they're one of the some of the richest cities in the world, but that doesn't necessarily mean that wealth is equally distributed, right? There are political factors that influence where people live, right? People want certainty in their lives, a certain amount of freedom, satisfactory and stable government. If there's war, obviously people are going to want to leave and migrate towards more secure areas, right? And sometimes there are other reasons, political reasons why people populations move where they do. Like this Canadian base called Alert, the most northerly community in the world, right? At least before the Soviet Union dissolved, right? It was close to the Soviet Union and allowed Canadians and Americans to watch for hostile military activities. Right. We've also got cultural factors that determine where people live. Right. People look for housing availability, safety, access to transportation, a feeling of belonging, whether that's through religion, roles and status of women, familial attitudes. Right. So you can think of the Mormons. Right. Think back U.S. history. Right. And historical factors as well. Right. This one's a little bit difficult to grasp, but basically, right, they're historical events, right, whether it's migrations or wars or events, right, that created permanent settlements, right? So once an area is, permanently settled, it tends to stay and grow, right? So for much of history, India, China, right, those have been ideal locations, and that's where population has grown ever since, right? But you could also think of historical factors like, imperialism, countries that have been under European control, as this map shows. Okay. Awesome. So, we've been looking at global scales here, thinking about it globally, right? But, okay, there we go. But, as the scale of inquiry changes, the relevance of certain factors like climate, elevation, and industrialization, they change as well, right? So going back to scales of analysis, right? So the scale you're looking at, whether it's global, regional, national, local, will show you different patterns, right? And we could be looking at physical factors, right? So on a global scale, high altitude areas like the Himalayas and the Rocky Mountains have cold climates. So, at least globally, we'll see that they have limited populations, right? However, if, elevation is not important at the global level, but at the city level, it could be important, right? Because people prefer to live at high elevations in cities because, these spots offer safety from floods, inspiring views of the landscape, right? So, I mean, you could picture Portland if you'd like, right? Climate, explains population distribution of large states as it does globally, right? We could also look at human factors, right, through different scales of analysis. So, pollution is definitely a health hazard, but it's also a sign of industrialization, economic development, and employment opportunities. So on a global or national scale, right, millions of people are going to be attracted to these areas of economic opportunities, and they're going to be willing to move into these. However, if we're looking at a city scale, at a local scale, few people will intentionally choose to live near pollution sources, right? Unless they have to live there because of low property values. Right, same deal with governments. Okay. All right. So again, we could also just look at population density in general at different scales, right? The national scale of analysis here, the local, right? Another local. And again, notice here how most people seem to be in Egypt are centered around the Nile River, right? Where obviously it's best for agriculture. Right? Again, here you might see, right, that the people per square kilometer, right? It might look huge. But the closer we look, it seems to be pretty dispersed for most of Egypt and then pretty clustered around the Nile River. All right, and even more so if we look at Cairo, Egypt. Right, so people are definitely close to the Nile here. All right, cool. So human factors, physical factors, right? Now we're moving on and looking a little bit more at population density. All right, so this will be the second learning objective. And, again, let's try to make the distinction here, right? Population distribution is the pattern of human settlement, the spread of people across the earth. However, population density tells us how clustered or dispersed a population is, the number of people occupying a unit of land. All right. So geographers lately haven't been as focused with population distribution as they have with population density, right? And they've been asking themselves, what impact is population density having in certain areas? Because population density has increased significantly over the years, while population distribution hasn't, right? And the reason why, or the reasons why for this, right, the vast majority of growth is occurring in places that are already settled, specifically Eastern China. Okay, and there are three types of population density, so to speak, that geographers use to determine the impact, right, that population density is having in areas. Specifically arithmetic density, physiological density, and agricultural density, right? So arithmetic density is the amount of people in a certain area, while physiological density is the amount of people within the arable, farmable land of a certain area, and agricultural density is the amount of farmers within the arable land of a certain area, all right? So these are calculated in different ways. Arithmetic density is calculated through population, divided by amount of land. Physiological density is divided by population versus arable land, and agricultural density is calculated farmers divided by arable land, right? So a little bit of math, but let's break these down here. All right. So arithmetic density simply calculates the total number of people per unit area of land. So usually when we see general population density maps, right, it's arithmetic density, right? So the general number, right? If the number is high, that means people are clustered together, right? If you see that the number is low, it means people are dispersed, all right? So like I said, this is general calculation because we're just dividing by the total amount of land, right? But some of that land could be uninhabited, right? Rather mountain ranges, rivers, maybe it's not fertile soil. So I mean, just think about Egypt again, right? Most of it is desert and a lot of the population is concentrated near the Nile River. So we won't be able to tell any specifics, just by calculating the arithmetic density of Egypt, right? Arithmetic density also tells us very little about distribution, right, of a population, right? Maybe it's an even distribution, maybe it's clustered, linear. We won't really know just by calculating arithmetic density. All right, again, calculate it by dividing a region's population by the total area. And so this is the United States arithmetic density. Right, it's population divided by total area, and we'll see that it's 83.6 people per square mile kilometer. So keep that in mind. It's per square mile, so mile squared, you could say. Right, and this map here just shows you the arithmetic density of different countries in the world. Okay. We could also look at, we could see the limitations of arithmetic density just by looking at Taiwan. All right, I mentioned Egypt, but it helps to actually see a country visually here. So Taiwan has one of the highest population densities in the world, arithmetic densities, but 75% of its people actually live on just 1/3 of its land. And roughly 30% of Taiwan's entire population lives in the greater urban area of Taipei. All right. 2/3 of the island is actually covered by high mountains, hence why we see a low population density right in this area. Right. So You'll see this chart in other slides here, but obviously here, arithmetic density. We could just see a sample of some countries here. Obviously, Iceland and Australia are pretty low. Not many people live in the most areas of that country, right? Same deal with Canada. Just because the further north you go, it's not necessarily desirable place to live, right? And one thing you can tell here is that, you know, these are pretty large countries: Iceland, Australia, Canada, the United States. And if you see the arithmetic density, you see the lower we go here, right? They're pretty high. And the reason for that is due to the fact that these countries are small and they're located in those regions of the world where most of the world's population is centered, right? Next up, we've got physiological density, right? And physiological density, again, population divided by arable land. And arable land is land that can produce food or grow crops, right? So basically, how much food per unit of land, right? So physiological density is a little bit more revealing than arithmetic because it tells us the level of stress we're putting on the land, right? Can people sustain themselves agriculturally, right? If the number is high, you know, that means that, you know, the people there, the country is putting more stress on the land as it needs high crop yields, right? So food, right? In some cases, you know, some countries might have an excess of food, so maybe they might sell it, right? But again, if the number is high, that country runs the risk of depleting nutrients in the soil, desertification, and sometimes high yields are not always possible. So if the number is high, not only does it say that they're probably putting stress on the land, but they're also probably relying on trade. Right? If the number is low, on the other hand, right, less stress on the land because they're producing less food, right? So where are they getting the food? They're probably, you know, taking in food, right? Again, it's more telling than arithmetic density, physiological, because it tells us the region's carrying capacity, how much population it can support without much environmental impact, right? And, you know, you don't have to do the work here, but, you know, geographers have determined, right, the percentage of arable land within countries. So when you get a piece of data, you know, you'll be able to tell, right, the percentage of arable land. And countries that have a low percentage of arable land often have a high physiological density, right? In this case, we could look at Egypt, 2.8% arable land with a high population, right? Arithmetic density, again, you know, we look at a map and we're like, oh, you know, it's not that much, right? 226 square miles population density, right? But if we calculate physiological density, right, then the number is huge, right? 8,078. So by comparing the two, right, this large gap indicates that a small percentage of land is capable of growing crops in Egypt and indicates the need for greater crop yields, right, which Egypt can't necessarily do. So they rely on imported food, right? And we can see some of the countries in the world that have pretty high physiological densities, right? Right, so many in Asia, right? The United States, not so much. Australia, not so much. Okay, awesome. We can calculate, you know, if you want to practice, right, you could pause it here and calculate the arithmetic density and physiological density just for practice, right, of Canada, right? And you'll see the arithmetic density is 3.78, physiological density 80.3. So not that high, right, when you compare it to Egypt, right? Same deal with Taiwan. If you want to practice, right, calculating arithmetic density, physiological density, you can do that, right? And in this case, you'll see a high gap here, right? Arithmetic density 704, physiological density 2,900. And this is probably saying, you know, that because the number is high, they're probably putting more stress on the land because they need high crop yields, because they need food. Okay. You could look at some other countries in recent times, right? This data is from 2018, right? You could look at the arithmetic density of each country here and compare it to the physiological density, right? So Kuwait, you know, you see a huge difference here. Same deal with, you know, Japan, Uganda, right? And Japan is just a little bit different than Egypt. They can actually afford to import food, so maybe they're not experiencing as much as Egypt is, right? Egypt and Japan both supplement crops through the fishing industry and with imported food, but it's easier for Japan, like I said, because they can afford it. All right. And of course, like I said, you don't need to calculate arable land necessarily, right? Geographers have done that for you. And like I said, right, countries with a low percentage of arable land often have high physiological densities. And we can see it right here with Singapore, 0.8% arable land, 2 million, right? It's the physiological density. Okay. If you're a little confused as to what these two mean, it's pretty easy to see here. Arithmetic density, of course, like I said, it's just calculating generally population, not taking into account, how spread out people are. Physiological density does, and you can see here the difference. Okay. Awesome. So agricultural density is next. And agricultural density is basically just trying to answer the question, how efficient is agriculture in society and how much tech does a country use, right? If the number is high, right, if agricultural density is high, that means more human labor is needed to produce food. And it'll also mean that that country is probably less economically developed. If the number is low, if agricultural density is low, less amount of people are needed to produce food, so they don't the country doesn't necessarily need a high amount of farmers, and there can be specialization elsewhere. People can focus on other things to do, right? Especially in the urban areas, right? It's a sign of a more developed nation if the number is low. They're more economically developed, right? And you can take a look at these two examples here. Bangladesh, agricultural density, 431 square miles. Compare that to the Netherlands at 31 square miles. Right, and you can see here that much of Asia, they're pretty high up there when it comes to agricultural density, right? And it makes sense, right? Because as I was saying earlier in this PowerPoint here, that China 50%, is rural. India, it's probably the same number, right? And you can see here in some of the more developed nations in the world, the United States, Canada, most of Europe, Australia, right? The agricultural density isn't as high. All right. So here you go, a little quick summary of these three. Arithmetic density calculates all people, all land. Physiological density calculates all people and arable land. And agricultural density calculates farmers and arable land. Okay. So the method used to calculate population density reveals different information about the pressure the population exerts on the land. All right. So again, right, arithmetic won't say much. Physiological will tell us, right, how much stress a country is putting on the land, on their land, and agricultural density tells us, how advanced, right, a country might be. Right, they tell us a lot, all right, and it's important not looking at them individually, but entirely, and between two countries, right? I mean, we could look at Egypt and the United States as an example, right? You can see here the numbers, right? I don't have to read them off. But again, arithmetic numbers, very deceiving. They don't paint the complete picture, right? But look at the physiological density numbers, right? What does the big change in physiological numbers tell us about each country, right? What does it tell us about the farmland? Why are these numbers so important, right? What does the agricultural density tell us about the country, right? The U.S. is at 0, but we still have farmers, right? Not that many as we did even 50 years ago, right? And typically speaking, the lower the numbers in these densities, typically the better off the state is. And when I mean state, I mean nation, all right? So a final word here for geographers, Population density can describe the human-environment interaction by looking at the distribution of people and the impact on its resources. Okay, I mean, we could look at this example here, right? The Sahel region of Africa, including the country of Mali, right, is threatened by overpopulation, right? The number of living people here isn't necessarily high, but the capacity of the environment to support life is extremely low, hence overpopulation, right? Think of overpopulation like that, not just some high number, right? These people are chopping down one of the few remaining trees in this region. It would be interesting. It would be interesting to see the physiological and agricultural density of this nation. Right. And 2 for 1 here, you guys. Topic 2.2, consequences of population distribution. Right. We're going to explain how population distribution and density affects society and the environment. Okay. So population distribution density affect political, economic, and social processes, including the provision of services like medical care. Right. And generally speaking, again, right, areas with large population densities and large populations, greater population densities, have greater political, economic, and social power than those countries with lower population density. So those that are more distributed, more dispersed. Right. So not the best PowerPoint here, right? But if we're looking at political factors, right? Larger populations, those with greater densities, are going to have greater influence nationwide, right? Because more people live there. They're going to have more resources. The government's going to pay particularly close attention to them, right? They're going to get more funding, right? While smaller populations, those more dispersed, right? Those in the rural areas, we could say, less funding, and they may not get as much influence on the nation, right? But the individuals there definitely have more influence than those in large cities where somebody is just another number. Right? Economic and social factors here, right? And larger population, larger densities, right? Urban areas, right? People are going to get more access to goods. They're going to get more access to jobs. Hospitals, businesses are going to get better revenue than if they were in rural areas, right? And the standard of living is greater. Right, and smaller populations, right, they're going to have less access to goods, less access to jobs, less access to hospitals, right? Rural areas or rural businesses are definitely going to depend on the community, so they're not necessarily going to get as many people, right, as urban businesses would, right? And the standard of living may not be the greatest in rural areas or more dispersed areas, right? Social factors here, right? If you're living in amongst a larger population, you're going to have greater access to healthcare, to education, to social services, right? Like the fire department. There's going to be greater cultural diversity, right? And families are going to be smaller, right? Because if you're living, in a big city, right, or where there are more people, right, it's gonna cost a little bit more to live in these areas, right? But going back to social services here, right? The operating costs of them are going to be lower, because they're going to be serving, they're going to be serving more people, but in, densely populated areas. So fire response times, for example, as firemen, right? It's going to be shorter for them to get to where they need to, right? As opposed to rural areas where population is going to be more dispersed. In addition, more densely populated areas need these public services, right? Because fires are going to pose a bigger threat to more inhabitants, right? And in those smaller populations, those more dispersed areas, there's going to be less access to those opportunities mentioned above. But there are going to be large families, so take that how you will. Right. And one last thing here with economic reasons, right? The more people who are born into or move into an area, right, the greater the need for access to adequate housing. So of course, urban areas are going to get dibs, we can say. Right. That to say, there are plenty of challenges that present themselves when it comes to high population areas, right? Such as the contamination of water supply for a downtown area, right? That can make people sick, right? Diseases are going to spread quicker. There's going to be food deserts, right? Urban areas and rural towns without ready access to fresh, healthy, affordable food, right? And we'll look more into that when we talk about cities specifically, right? There are going to be high crime rates, right? Maybe when you're living in a high population area, it may not be as easy to find jobs, right? Less nature, right? The urban sprawl, right? Cities expanding, right? Less populated areas on the other hand, right? There's less pollution, more people going out, lots of agriculture. Still issues though when it comes to agriculture, like pesticides and bad fertilizers. Okay, so as population grows and communities expand, we start to alter the environment and landscape. And this is the big takeaway here, right? We need more space to grow food and to house people, right? So what do human beings do? What do we do, right? Pretty easy answer, right? We take the natural landscape around us, we chop down the trees, we build houses, we build apartments, high-rise buildings, businesses, right? But this, presents a lot of problems because the loss of the natural landscape is irreversible in some cases, right? And it's pretty hard to reverse all of them, right? So as population grows and communities expand, we start to use more natural resources, which again, right, pressure on arable land, right? And this leads me to talk about, carrying capacity, right? The maximum population size in an environment can sustain without depletion or loss of natural resources. Higher population density creates strain on the environment, right? And this can lead to overpopulation, right? More people than what the environment can support, right? An area with high population density may not be considered overpopulated if the area has a high carrying capacity, right? Because of fertile soil or modern farming techniques, right? So, there are two sides to it, right? That being said, carrying capacity can and does increase and decrease, right? Either because of new technology or farming practices. Natural disasters can reduce the carrying capacity, right? Because natural disasters can cause serious damage, right? Other factors that make carrying capacity increase or decrease. Cool. So the impact of population distribution on the environment, right? Urban areas with dense populations increasingly impact the environment through pollution and resource use, right? Whether it's from vehicles, heating and cooling sources, industrialization, high consumption of energy, and the generation of excess amounts of waste, right? Sewage and industrial waste can lead to many lakes and rivers no longer providing drinkable water, right? And you don't need to look any further than the Willamette River in Portland, which has a very dirty history. Okay. Hey guys, um, so that's it for 2.1 and 2.2. A lot to cover there, but I think it's a lot of it comes down to looking at some examples here, and I'll be exploring these a little bit more as we go through the unit. So yeah, if you have any questions, email me, shoot me a message, and I'll get back to you. All right, until next time.